Okay, welcome back. If you're having a little look at this because you don't quite understand what's being asked of you on the sheet, or you're a bit stuck, then that's all good. If you've actually been through and had a little go and now you're going to have a go just to see how you got on, then that's good too. So we're going to go through together to work out the answers and show you the answers and how we did it. Okay, so these first few are very similar to the ones that we saw on the slides. So basically we've got to convert this mixed number, which is 2 3/4, into an improper fraction. And straight away we know that we are working with quarters because this denominator is quarter, and they'll always stay the same. Okay, whenever we're doing that, it will stay the same. We don't change that. If we do, it starts to get very complicated. So the denominator is the same, so we know that's going to be 4. So then all we need to do is we need to count the shaded area. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the answer is 11 quarters. So 2 3/4 equals 11 quarters. Yeah? Okay, we move on to the next one. And again, we're looking at the denominator, it's eighths. So we know that's not going to change. That will stay the same. We keep that there. And we say, right, how many fractions have we got that are shaded? And we can count in eighths if we want to, like 8, 16, 17, 18, 19. So it's 19 eighths. So from 2 whole ones and 3 eighths, we get 19 eighths. That's the improper fraction. And then again, on this one down here, we're working with eighths again. So we make sure that denominator stays the same. We don't change that. That stays the same. So then what we do, we can count individually each section if you want to get the answer, or if you're really good with your tables, if you're quite happy to count in eights, you can go 8, 16, 24, and then we've got 3 left here, 25, 26, 27, so that's 27 eighths. Okay, so that's the first question, that's those ones done. Right, and they, because of what we've done previously, they should be quite straightforward. It's very similar to what we've done this week so far, which is what I really like about this scheme of work. It builds upon everything that we've been doing. So hopefully when you come to see this, nothing is new. Okay, so this next one, okay, is again we are converting this number here into an improper fraction, but this time we're doing it without anything being shaded. Okay, so we know just by looking at this that we are working in quarters, and we know that as well because we can count 1, 2, 3, 4. Okay, so we know straight away the denominator, the bottom number, is going to be quarters. Alright, so now what we need to do is, and again if you want to do, it says 2 here. Okay, so you've got 2, so you could colour in 2 complete bars and then just 1 of the 4, because that's what that means, 1 of the 4 on the last one, and that gives you this nice shaded model then. And then what you can do, you can go, right, now I've done that and I've shaded it, I've shaded my 2 1/4, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, and that means that the answer is 9 quarters. We could do the same down here. This time though, we are working in thirds. We can see that because the denominator is there, that's a third, but also there's 1, 2, 3 boxes. Okay, but we know that there are 2 complete boxes, so we colour in 1, 2, 3, 1, 2, 3, because that's 2 holes. Okay, 2 complete shapes, 2 complete bars are coloured in, but we're left with this 1/3, so we colour in 1 part of the 3, and that gives us 2 1/3, 2 holes and 1/3. Now what we need to do is we need to work out what this number is. We know it's thirds, so we can put that in straight away, and then we can count the shady bits. 1, 2, 3, 4, 5, 6, 7, 7 thirds. Oh, here we go. It's getting a bit longer, this one. There's quite a few more bars on this. So again, we've got this time we're working in thirds again, so we know that this denominator is going to be thirds, so we put a third there. Okay, so we're working with 3. I don't know what happened there. 3 1/3. Okay, You've got these nice blank boxes, or they will be on your sheet. And then what you do, you think, right, this is the number here, 3. 3 complete bars need to be coloured in. So 1, 2, 3. That's 3 complete bars, 3 whole bars. Yeah? And we're left with 1/3, 1 part of 3. So we colour in 1 part of the 3. And that shows us 3 1/3. 1, 2, 3, and 1/3. So now what we can do is we can count all our shaded parts to give us the answer. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the answer is 10/3. So 3 1/3 is the same as 10/3. And we could also say, like, what's 3 times 3? It's 9. Add 1 more is 10. Okay. Same up here. What's 2 times 3? 6. Add 1 more, 7. Right, moving down to this D down here. So now we're looking at fifths. I haven't worked for fifths in this column yet, so we're working with fifths. We know it's fifths because the denominator there says fifths, and because there's 1, 2, 3, 4, 5 boxes. Okay, so what we need to do is we need to colour in 3 complete boxes because there's 3 whole ones. 3 complete blocks. So it's 1, 2, 3 has been coloured in, and then for the last bit we need to colour the fraction here, which is 2/5. So we need to colour in 2 of the 5 parts, because that's what that means. That numerator means that 2 of the 5 parts are coloured. Alright? So now we've done that. We've got 1, 2, 3, and 2/5. And now what we can do is we can add them up. We can count them. Okay, count the shaded parts. So 5, 10, 15, and then we've got 2 down here, 16, 17. So the answer is 17/5. And again, we can try that out by going, right, what's 3 times 5? It's 15. Add the 2 is 17. Nice work. Like that. Gets you thinking, doesn't it? Gets the old brains going, especially this time of night. Right, next time we're going to convert the mixed number to an improper fraction and write the next conversion in each part. So there's a pattern here, okay, which will help you, because once you've got this one up here, you should then be able to get the rest of them below. Alright, so we've got 2 1/7, and to work that out, we can, you could either draw the bars, the sevenths, and you could draw 2 complete ones, and then 1 down here with just 1 shaded in, or you can do a little multiplication trick. So you can go, right, 2 times 7 is 14, then we add that 1 more at the top there, gives us 15/7. Okay, so we know there's a pattern going on here. So we've got 15/7. So this one here, the fraction is 1 more, so it's 2 1/7 there, and that's 2 2/7. Okay, so if we go, right, 2 times 7 is 14, add 2 is 16, so it's 16/7. So we're starting to see a pattern. It's 15/7, 16/7. Now we go down 17/7, because 2 times 7 is 14, add 3 is 17. Now we have to finish off this little conversion. So it's 2 1/7, 2 2/7, 2 3/7. This one is going to be 2 and 4/7. Okay, and then we've got 15/7, 16/7, 17/7. That answer has got to be 18/7, hasn't it? That one's it. Nice little pattern there, nice and easy. Okay, now it gets a little bit trickier, because we've got 3 1/5, 4 1/5, 5 1/5. So we're moving up quite a lot each time. Okay, so first of all we need to work out what 3 1/5 is. So we can go 3 times 5, 15, add the 1, gives us 16, so it's 16/5. Okay, and each time we're working with fifths, because the denominator shows us 5, yeah? Each time. So you could put that in. You can actually put that in each box, a line with 5 underneath it, because you know that's the fraction we're working with. So 3 1/5 is the same as 16/5. Right, now we go down to this one, and we go, right, 4 5s are 20, add 1 is 21, that's 21/5. Can I see a pattern yet with these two? Probably not. when we get down to this one, we may start to see a pattern. So 5 times 5 is 25. Add the 1 is 26. That's 26 fifths. So we've got 16, 21, 26. So each time they are going up in, if you said 5, you'd be absolutely right. Okay, so we've got 3 and 1/5, 4 and 1/5, 5 and 1/5. In here is going to be 6 and 1/5. Alright, so we can work out, right, 6 times 5 is 30, add the 1 is 31, so it's 31 fifths. If you're really clever, you could just count on 5 from 26 to get the 31. But it's up to you how you do it. Right. Oh, I'm looking at this one, I'm thinking, crumbs, this is a challenge, because we've got different denominators each time. Okay? We've got the same whole number, but we've got different denominators. So what we could do is go, right, we know this is halves, so we're going to put a 2 there. We know this is going to be quarters, so we're going to put a 4 there. We know this is going to be 8, so we're going to put 16 there. That's very interesting that they've done that. I'll have a little look in a minute. We'll check that out. They may have got that wrong. I think they possibly have. That should be 8. So they've made a mistake. That should be 8. There we go. We've checked it out. White Rose, you've made a mistake. Okay, so it's 2, 4, 8. Because each time the numerator is doubling. And that should be the same as that. So this one is 16. Okay, so 5 1/2. So we go 5 times 2 is 10. Add the 1 is 11. So it's 11 halves. Now we're working with quarters. So we go 5 times 4 is 20. Add the 1 is 21. So that's 21 quarters. Sort of see a little bit of a pattern going on here as well. So this one we go 5 and 1/8. Okay, so 5 times 8 is 40. Add the 1 is 41. So it should be 41 eighths. So we've got 11, 21, 41. And now, because we are doubling the denominator each time, it's going to be 5 and 1. What's double 8? 16, of course. So 5 and 1/16. Okay, so this means that this denominator is 16. They've got that right. Okay. So now we go 5 times 16. And what I would do with that, because 5 times 16 is very hard, I'd go, right, what's 10 times 16? Because, of course, when we times by 10, we have a 0 on the end. 10 times 16 is 160. And then I would half it. So I'd say, right, what's half of 16? It's 8. Okay? So it's 80. So half of 160 is 80. And then I add another 1. So it's 81 sixteenths. So there's a pattern there. It goes 11, 21, 41, 81. So this number here, in this column here, is doubling each time. 1, 2, 4, 8. Alright? It's a good one, that. Nice to think about it. Right. I like this. So here are 4 whole pizzas and 3/5 of a pizza. How many children can have a fifth of a pizza? Okay, and what you could do is, because we know we're working in 5s, this number here is going to be a whole number. You could just count the pieces. Okay, you could count them and get the answer. Or, do you know what you could do? 5, 10, 15, 20, add the 3 is 23. So 23 children can have a fifth of the pizza. Or Mr. Andre could have all 23 pieces to himself, because he likes a bit of pizza and doesn't have it very often. Whitney, good old Whitney, number 5, is converting mixed number to improper fractions. So she's got 4 and 1/7 equals 28/7. And it asks you a question there, do you agree with Whitney? Explain your answer. Now what I'm going to do is I'm going to have a little look and see if I can work it out. Okay, so she said 4 and 1/7 is 28/7. So 4 times 7 is 28. She's done that bit right, but actually she's forgotten to add the extra 7th, which is there. Okay, so she's done 4 times 7 is 28, which she's put there, but she's forgotten this number here. She's forgotten this extra fraction, this extra seventh. So 27. So it should be 28, but she should add that, so it should be 29 sevenths. Okay, so 4 times 7 is 28. Add the 1 there, it's 29. So 29 sevenths. That's what she's forgotten to do. And then lastly, number 6. This looks quite tricky, doesn't it? So this table shows some possible values of the circle. Use this to find a corresponding value of the triangle. So basically you go through, so the circle, this is the value of the circle each time, this is the value of the triangle. Okay, so the value of the triangle is 1, 1 and 3/3. Okay, what you do is you go, right, what's 1 times 5? 5, add the 3 is 8. So the triangle is going to be 8. We have 2, we go 2 there. Okay, what's 2 times 5? It's 10. Add the 3 is 13. Right, if this number is 4, so 4 and 3/5. Okay, so what's 4 times 5? Yeah, 20. Add the 3 is 23. So the triangle would be 23. If you have 8 here, 8 and 3/5, you go 8 times 5, which is 40, add the 3, which is 43. So the answer for the triangle is 43. Now we're getting pretty tasty with some of these. Now we're getting up to 16. So 16 and 3/5. And remember we looked at 16 over here. Okay, so we've got a rough idea of what it is anyway. So 16 and 3/5. So 5 times 16, or 16 times 5. And again, what I would do, 10 times 16 is 160, and I would half that, so it's 80. So 80, add the 3 is 83, and that's the answer for the triangle there. Next one, we've got 17. Whoa, there's some crazy stuff going on here. So 17, I don't know why they've put 160 there, but still they have. Oh, just because we've got the answer there. Got you. Okay. So we've got the answer this time. We don't have the circle, so we've got 88 here. So it'll be 88/5. So basically what you have to do here is you have to work out how many 5s are in 88. Okay, how many 5s are in 88? And again, you can count 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85. That's 17 and 3/5. Okay, that's the other way around. We have to do it this time. This one's huge. Look at this, 803/5. Okay, how many 5s in 803? And what I would do is I would do a division problem. I would do a doorstop problem to work that out. Okay, that would be the easiest thing for me. I would definitely do that. Okay, so what I do is, like, how many 5s are in 8? We know there's 1. Okay, with 3 left over. How many 5s are in 30? There's the 1 there. How many 5s in 30? There are 6. Okay. How many 5s in 3? There aren't any. That's the remainder. The remainder 3, which we then turn into a fraction, 3/5. And that are the answers for today. Like I say, if you finish those and you want a little bit more of a challenge, I will put in an extra sheet for you converting improper fractions. Oh, sorry, proper fractions, or mixed number to improper fractions. Okay, hope that helped. That was quite, I had to, especially this, I had to really think about these. But it's good when you get to when you have to think, when it gets your brain going. So thank you again for listening. Hope you enjoyed the maths session today. I'm really enjoying these fractions. I'm working and enjoying with the children in the class on them as well. But I'm really enjoying seeing your learning at home too. So thank you. Take care.